Hi children, how are you? In today's class, we will learn about characteristics of mixture. A mixture has, what are the characteristics a mixture will have? See, there will be different characteristics of a mixture. First one is variable composition. The mixture can be taken as in variable composition. The constituent of mixtures are present in any ratio. For example, 1 gram NaCl can combine with 2 grams of carbon. NaCl means salt, carbon is charcoal, powder of charcoal. And 1 gram of sodium chloride may combine with 1 gram of carbon. 2 grams of sodium chloride may combine with 1 gram of carbon. So likewise, in variable composition they may combine those mixtures. They don't have any fixed ratio. Second one, physical change. The constituent of mixture do not bind each other by any chemical force, thus forming a physical change. There is no chemical change there will be. In the mixture of a common salt and powder charcoal, NaCl and carbon particles do not bind chemically. Okay, they simply mix together, salt and charcoal, and they can be easily supported. They can be easily separated also. See, no specific properties. The properties of the mixture are the average of the properties of constituents, and they don't have separate property. For example, in the mixture of common salt and powder charcoal, common salt is white and soluble in water, and charcoal is black and insoluble in water. See now, homogeneity. A mixture can be homogeneous or heterogeneous. For example, mixture of common salt and charcoal is heterogeneous, and common salt and water is homogeneous because it completely combines. Separation of constituents. The constituent of mixture can be separated by employing a suitable physical means. For example, charcoal can be separated from the mixture of charcoal and common salt by dissolving it in water. If you dissolve combination of charcoal and common salt in water, that common salt, sodium chloride, will react with water and dissolve in water, and the remaining charcoal will be undissolved. So NaCl plus charcoal plus water, salt solution is going to be formed, and we can separate charcoal from salt solution. Exchange of any energy changes. No energy changes takes place. There is no energy is going to be released during the formation of mixture. For example, when we mix the powder charcoal and common salt, in that mixture there is no energy is necessary to combine them. Next thing, mixtures versus compounds. To observe the difference between mixture of iron sulfur and a compound iron sulfide. See here, this is a beautiful thing. You can analyze the thing. First we take iron and sulfur. See, for this the material required is iron fillings, iron small pieces, sulfur powder and magnifying glass, okay, whatsoever. See this, what we have to do. First take small amount of iron and sulfur. Iron will be grey in color, sulfur will be yellow color, and they both mix thoroughly, both of them, in a small bowl. Divide the mixture into 2 parts. Okay, after mixing it, divide them into 2 parts. Take 1 part and heat it. If you heat it, you will get red hot glow and black solid will be formed. So that is chemical reaction after heating. So that is called ferrous sulfide, iron sulfide or ferrous sulfide. And iron react with sulfur, on heating it forms ferrous sulfide. See, you take part A. Part A is ferrous sulfide and part B is normal mixture of iron and sulfur. Part A seems to be red glow during heat, and after formation black solid and new substance has formed, that is iron sulfide. But part B, it is visible, particles will be visible as it is green and yellow and can be separated by physical means. Conclusion: mixtures are heterogeneous in nature and compounds are homogeneous in nature. Mixtures are non-uniform as that of iron and sulfur visible. Compounds are uniform and new substance is going to be formed. Mixture can be separated by physical means and compounds cannot be separated. Next thing, same thing, this is in different form we have given. If you want to choose separating of mixture and compounds, and the same thing I have explained in different form. If you want, see here what we have used is mix of iron and sulfur. Iron filings will be grey in color, sulfur will be yellow. You just try to mix together. In order to separate them, bring the magnet near the mixture. Iron filings, they are be attracted to the magnet, and remaining this sulfur sulfate, sulfur will not attract. It gets separated easily. We can easily separate. We can conclude that constituent of the mixture can be separated by physical methods, but compounds cannot be separated by physical method. There, in case of iron sulfide, if you bring magnet near it, magnet will not attract to iron sulfide because it is chemically combined one. Even after grinding, cannot be separated iron and sulfur. So these are the two ways of separation. Okay. Next thing, the differences between mixtures and compounds. Two or more constituents, they may be elements or compounds, mix it together in a ratio to form a mixture. They do not combine chemically. They are mixed with any ratio, these mixtures. Compounds are those two or more elements they chemically combined in a fixed ratio, and they will be called as compound. They cannot be separated by physical means. Mixtures may be homogeneous or heterogeneous, and compounds are always homogeneous. The constituents can be present in any desired ratio. There will be the fixed ratio. The constituents of the mixture retain their individual physical properties, physical and chemical properties. They don't retain individual properties. They form the new substance. The constituents of the mixture can be separated by physical means, which cannot be separated by physical means, that is compounds. During the formation of mixture, no energy changes takes place. There the energy changes takes place. So, right. So this is the thing. Next one, why air is regarded as mixture? See, following reasons will prove that air is a mixture. Air is a mixture of several gases like oxygen, nitrogen, carbon dioxide, etc., and even water vapor will be present. Okay, which retain their individual properties. That is why air is considered as mixture. Two or more elements chemically combined in a fixed ratio is called compound. They don't retain their. So that is the thing. Here, in case of combustion, the composition of air changes from place to place. Okay, so place to place, and near the bigger industrial area we will expect more carbon dioxide, and in similarly in higher altitudes such as mountains, the amount of oxygen in air is going to be decreased. Especially why the amount of oxygen is going to be decreased in case of the higher altitude, because its density is going to be decreased. Density is decreased in the sense, suppose in the lower area you consider this much of area, and in the same time in higher areas, higher altitude, you consider the same area. The oxygen molecules present in the air will be differ in these two areas. In mountain region, the oxygen molecules will be very less, as the oxygen density is more, it will be in lower altitude, and in higher area, in lower area we will find much oxygen molecules. That is why in lower area we have much oxygen is available, its density is more, so we can breathe easily. There we cannot breathe. One more beautiful question here. During burning, only oxygen gas helps us in burning, but not other gases. Why? See children, air is a mixture of different gases. Almost all much amount of air consists of nitrogen around 78%, the oxygen will be around 20-21%, and little bit of more carbon dioxide and other gases. What happens here is oxygen support for combustion. I mean there the oxidation takes place. Oxygen react with the substances during burning. During burning, the oxygen react with substances and it will release heat and light. But in case of nitrogen, it is chemically less reactive. It does not react easily with the fuels. So it does not support burning. Which one? Nitrogen. Carbon dioxide, it is fully oxidized gas. Already it is oxidized. Carbon dioxide, it contains oxygen already. It cannot further burn or support for burning. It cannot give support for burning. That is why it is used in fire extinguishers. Okay, fire extinguisher to stop the fire. So that is why likewise the oxygen is very helpful in burning. Overall, all gases in burning, the oxygen is the only thing which helps in burning. And there is water vapor also. It reduces fire instead of supporting it. So all the remaining things, they will not support in fire, for support in burning, and only oxygen will support us. During the formation of mixture, no energy changes takes place. Here the energy changes takes place in case of formation of compound. Next thing children, see here also we are having the beautiful concept. Hydrogen and oxygen in water exists in the ratio 1:2 because in H2O the hydrogen atomic number is 1. So hydrogen in 2 compounds, so 2 into 1 is 2, and oxygen mass number is 32. 2:32 in the sense if you divide that, hydrogen mass number is 2 and oxygen mass number is 32. If you divide that, you will get the ratio as the oxygen atomic number is 16. If you divide that, it will get the ratio 1:8. So the oxygen and hydrogen ratio is, hydrogen and oxygen ratio is 1:8 by weight. Okay, it means water has a homogeneous composition. See, actually 2 hydrogen molecules, two hydrogen atoms combine together to form a hydrogen molecule, 2 oxygen atoms combine together to form a oxygen molecule. How they both are combining and forming water molecule here? In between hydrogen and hydrogen we will have single bond. In between oxygen and oxygen we are having double bond. Don't worry children, in future we are going to learn what is single bond, what is double bond, everything. The double bond is more stronger when compared to single bond. In order to break hydrogen-hydrogen bond, we require less energy. In order to break the molecules between oxygen and oxygen, we need more energy. Here of course we may get a question. H2O, the formation of the molecule is H2O. I think you may assume that H2 is already there and there is no need to break H2. If you break O2 and combine with one O with H2, it will form water molecule. No, it is not the thing. Actually, H2 will break first. In order to break H2, some amount of energy is lost. In order to break oxygen molecule, much amount of energy is going to be lost. The energy is losing here. That energy should be converted into some other forms. After formation of these 2, hydrogen, oxygen, these 2 different hydrogen atoms combine with one oxygen and form a new molecule, that is H2O. Okay, so that is called water. While forming, less energy is required. Already much energy has spent in order to divide hydrogen bond and oxygen bond, double bond and here single bond. So we had only less amount of energy we have consumed here in order to form water molecule, and there is lot of energy remaining. That energy will be liberated in the form of heat. That is why this reaction we call it as exothermic reaction. You learn, children, see, for every formation there will be the reason. Without reason, don't try to study, children. Okay, so try to get the questions. You try to ask the questions. Why it is happened? How it is happened? Why it should not be like that? Why it should be like this? Then only you can learn the things, and then only you can get the things. The composition of water cannot be separated by physical means such as filtration or boiling. When one part of the hydrogen by weight is burnt with 8 parts of oxygen by weight to form water, a large amount of the heat energy is liberated. I already told you how the large energy is going to be liberated. Okay, that is the reason. The properties of water are entirely different from that of the properties of its constituents, that is hydrogen and water. Okay, that is why water is considered as water is a liquid which extinguishes fire, and water is considered as a compound. Okay, children, thank you. If you have any doubt in my concept, you try to comment below that. You ask questions. I try to clarify each and every question. If you have any doubt, even I will do a separate video to make it clear. Don't worry, children. I will give clarity of every concept, and try to share as much as possible. Try to subscribe, share and like my video. Bye.